Morning students, today we will study class 8 chapter 11, that is force and pressure. In previous lecture we had discussed about the force and their characteristics. In today's lecture I will discuss about the types of forces and the term pressure and how it is represented in day-to-day life. So firstly, I will deal with the types of forces. So there are two types of force, contact force and number two is non-contact force. So the contact force, as the name indicates, is a force in which the two objects are in contact. So this force only applies when the two objects are in contact. So the contact force is of two types. Number one, muscular force and number two is frictional force. So first is muscular force. The force which results due to the action of muscles. So what does it mean? It means during the action of muscles, the force come into play. That force is called muscular force. For example, if we are lifting a bucket, if I am lifting this pen or I am holding this pen, the force acting on this pen while contact between pen and hand, and that force due to the muscles is called muscular force. For example, animals digest their food. So during digestion, there is contraction and relaxation of muscles take place. So this is also the example of muscular force. So number two is frictional force. So the frictional force come into play when the body is in contact or contact and in motion. So it acts on the object that are moving. If the objects are moving, then the force that is acting on the object is frictional force. So one point should be clear that number one, the object should be in motion. Number two, the two objects are in contact. And number three, the direction of force of friction is opposite to the direction of motion. So the direction is opposite to direction of motion. For example, if I am moving in this direction, then the force of friction is acting in opposite direction. If I am moving in east direction, then the force of friction is in west direction. If I am moving in north direction, then the force of friction is in south direction. So in this way, the force of friction is very useful. So for examples, the force of friction is helpful in writing by chalk on blackboard because it creates a contact between blackboard and chalk. So it is also helpful in writing with pen on paper. So it creates a friction between pen and paper so that we can write smoothly. Is that clear to you? So next is non-contact force. So simply the non-contact force simply give the information about the two bodies are not in contact. They are a distance apart. For this, there are of three types. Number one, magnetic force, electrostatic force, and number three is gravitational force. So firstly, number one, magnetic force. As you all know, magnet has two poles, that is north pole and south pole. Magnet has property of attraction and repulsion. So when two magnets come close to each other, they got attracted or repulsive. If both have same poles, north pole or south pole, they repel each other. If they both have opposite poles, north pole and other one is south pole, then they attract each other. So when they attract each other or repel each other, there is just like push or pull. So this push or pull during a magnet attraction or two bodies without contact, the force is called magnetic force. So we can say that the force exerted by magnet on other magnet or other magnetic materials. As the magnet come close to the almirah of iron, so it got contact with the almirah. So next is electrostatic force. So electro means electrons or charge. Static means stable or not moving. So the force exerted by charged body on another charged body. So when the force is exerted between two bodies that are charged but that are not in contact, then we can say that electrostatic force of attraction. In childhood or in today's period, you will try to rub your scale on your hairs and try to pull the piece of paper with this scale. Have you done this activity in your childhood? Yes, of course, everyone has done it. You just rub your scale on your hairs, on your head, and try to pull a piece of paper with this scale without being in contact. In this section, the paper comes up to the scale. So we can say that the force between these two is electrostatic force. Next is gravitational force. So gravitational is the force exerted between the object and gravity. As we know, everything is falling of leaves, falling of pen from a certain height, and you try to pull your hand try to go down. So you should apply a force to go your hand up. So when you stay your hand as it is without any force, it goes down. So in this way, we can say that the force that is acted on a body without being contact by the earth, that is called gravitational force. For example, as we know, there is an attractive force. Everything in the universe is attracted by the object. If the force of gravity is more than the force occurred by the body, then the object doesn't fall down. The object falls down. If the force of gravity is more than the force occurred by the body, then the object falls down. Every object is falls on the ground due to the force of gravity. That force of gravity is called gravitational force. Is that clear? So here we had done the types of forces. And now I will start the next term, that is pressure. So what is pressure? The pressure is a force acting normal to the surface. Normal means perpendicular. Perpendicular means 90 degree. Like this. If the surface is this, then the force acting like this. If the surface is this, then the force acting like this. So there is the angle between this and this is 90. So we can say that the force which is acting on a surface perpendicularly is called pressure. Force acting on a unit area of surface perpendicularly is called pressure. So mathematically, pressure is force upon area. What is the formula of pressure? That is force over area. Is that clear? So here kept in mind. See, pressure is directly to force. Directly means it is as on the same level. So we can say that if force is higher, then pressure is higher. But area is down here. It is not under the same. It is, we can say that it is inverse. So here area is inversely proportional to pressure. Inversely means opposite. Here force is directly proportional to pressure. Directly means as it is. As pressure increases, then force increases. Pressure decreases, force decreases. Force decreases, pressure decreases. So they are directly with each other, direct contact but the area is inversely to this. So here pressure is inversely proportional to area. But so when pressure increases, area decreases. When pressure increases, area decreases. When pressure decreases, area increases. So here you can see when pressure increases, area decreases. When pressure increases, force increases. So kept in mind, pressure and force are directly to each other, but pressure and area are inversely to each other. So some are the examples which governed by this formula. Number one, the potter places a round piece of cloth over its head. When a coolie or a potter place some luggage on their head, they put some round cloth on their head. By putting this round cloth, they increase the area. So increase the area so that luggage can be put. As the area increases, what happens to pressure? Pressure decreases. So when the potter places some round cloth over its head to carry the luggage, the area got increases that contact with the luggage. So as the area increases, what happens? Pressure decreases. So less pressure is attacked on the head of the potter. So clear? This formula is helpful by knowing these questions of day-to-day life. Next, area of pointed end of nail is smaller. As this pen has pointed head or the nail has pointed head, so that it can go inside with the hammer easily. So why it go inside? When the area is smaller, then pressure is higher. When the area is smaller, we need a higher pressure. If I want to try to add this area in the blackboard by doing the pressure, as area increases, pressure decreases. So less pressure, take more time to go inside. So that's why the nail has sharp end. For example, your cutting tools have sharp end. For example, knife, scissor has sharp end. Why they have sharp ends? Because their sharp end means area decreases. When area decreases, the pressure is increases. So more pressure is applied on a vegetable or a fruit so that they can cut easily. Next is shoulder bags have broad strip. When you are putting your school bags, you have broad shoulders there. So broad shoulder means area increases. So area increases, pressure decreases. So when pressure decreases, there is less load on your shoulders. You can easily put your bag up. So these are the day-to-day example which governs that law, pressure is force upon area. So next is pressure exerted by liquid and gases. So here liquid exert pressure on walls of container. So here is the activity in your book, you can see. It shows that the pressure exerted by water at the bottom of the container depends upon height of the column. You can see here the height of column is this. So the balloon is not bulged. As the balloon is bulged, the height is increasing, which means there is certain pressure that is exerted by the liquid on the surface. Liquid exert pressure at same depth. So here is the activity. You can see a bottle and you have a hole on the bottle on the same depth, so that the water comes out easily. You can see here, if the depth of the holes on the bottle is same, then they comes out with equal pressure on the surface. Next is air exert pressure in all directions. So air exert pressure in all directions means when you use the inflated balloon, you try to push that balloon, and when you push that balloon or when release that balloon, it comes out with the same pressure on whole area. So it shows that air exert pressure in all directions. There are certain other examples that show with increase in depth, with increase in height, with increase in depth, The air pressure is also, liquid pressure is increases. So as depth increases, pressure increases. Is that clear? So the next topic is atmospheric pressure. So as we know, we have an envelope of air all around us. So as we have the air envelope all around us, so the envelope of air around us is called atmosphere. So the air exert a pressure, that atmosphere exert a pressure on us is called atmosphere. So here you can see the pressure inside our body is equal to the pressure of the atmosphere or outside pressure. That's why our body don't crump or shrink with the pressure or force of gravity. If the pressure inside or outside are not equal, then our body become shrinked or crumbed like a piece of paper. So why it is not crumbed? It is not crumbed due to the equal pressure that is inside or outside. Is that clear? Okay. Here we had completed the chapter number 11, that is force and pressure. In next lecture I will discuss with the next chapter. So here you have to revise that chapter, and after the day tomorrow you will get a test. So that's why you will be prepared for this chapter. So day after tomorrow there will be a test of chapter number 11 of class 8, that is subject science. So be prepared and write test and test supplement.